Hello again, AP Calculus class. For today's session, we're going to be reviewing concavity of functions and what they are. So, first of all, what exactly is concavity? It's quite hard to describe in words. A visual representation is best for this particular concept, but in words, concavity is a representation of how the slope is behaving for a function f of x. The concavity can be concave up, meaning that the slope of f of x is increasing, or it can be concave down, meaning that the slope is decreasing. I know it sounds complicated, but a visual representation is more suited. So now this is a visual. You just gotta memorize this, okay? As I stated before, there are two different types of concavity, concave up and concave down. For concave up, these are the two different types of the visual representations that you may see. A graph will behave in this manner, or a graph can be behaving in this manner. For concave down, a graph behaves in this manner, going like that, or a graph can behave in that manner. Again, just memorize this. There's no easier way to go across. Okay, now how to quote-unquote solve concavity. To solve concavity, you have to take the second derivative, meaning that after taking the first derivative, you have to take the derivative of the first derivative, also known as the second derivative. The second derivative is also denoted as f double prime of x. Upon taking the second derivative, we have to make that new function equal to 0. In doing so, we are solving the second derivative, and we get values of x that makes the second derivative equal to 0. These x values that make the second derivative equal to 0 are known as points of inflection. These points of inflections are x values at which the concavity of the graph changes. This is complicated, but it's actually easier done than said. And afterwards, we test values that precede and go beyond x, also known as testing the second derivative. Okay, now this seems super complicated, but let's actually try to solve the problem. Okay, examples. This is the typical wording you'll encounter in the AP Calculus exam. Find the intervals where f of x is concave up and concave down. Okay, now this. We are given the function f of x equals x to the power of 4 minus 4x cubed. Now how do we solve this? As I stated before, the first step you have to do is find the second derivative. To do so, you have to first find the first derivative. So let's do that first. So f prime of x, and I'm assuming that all of you guys know how to do derivatives. F prime of x equals 4x cubed minus 12x squared. Then we find the derivative of this. Again, this is the type of denotation you'll see. F double prime of x equals 12x squared minus 24x. Now we have to solve the values of x that make this equal to 0. So I'm just going to make it 0 immediately. And there's various ways to do this, but immediately I see a common factor, 12x. So I'm going to take the 12x out. So that will leave me with the inner piece, x minus 2. And again, we have to equal that to 0. So what values of x make this function equal to 0? It's very simple. X equals to 0, and x equals 2. We actually haven't solved this particular question, because they asked for the intervals, right? At which the graph is concave up and concave down. And remember what I said, we have to test the values that go before the x values and go after the x values. It does not really matter which values you choose. And a quote-unquote trick you can use, or an easy method you can use, is to create a small table. So I'm going to put, so the table is going to look like this. And remember, when creating the table, you're inputting x values into the second derivative, not the actual function itself. Okay, now let's just choose some values that go before 0. Let's just choose an easy one, -1. Then we put the actual point of inflection, or the actual x value, 0. So now what's the value that goes after x, after the first x value, but before the second x value? Let's just choose something, 1. Okay, now that's convenient because 1 also goes before 2. So we just write 2 down here. And what's the value that goes after 2? Let's just write 3. And remember, 0 and 2 creates a value of 0 for the second derivative. So you don't really need to input anything, just put 0 and 0 for these two values. Now, to find the intervals at which it's concave down and concave up, let's try inputting -1 into the second derivative. This, putting -1 gives a value of 36, which is a positive value. Now let's try inputting 1, a value of 1 into the second derivative. Well, it provides a value of -2, a -12, or a negative value. Now lastly, let's input x equals 3. You get 36, or a positive value. So what do we do with this? You know, you remember what I stated before, there are two different types of concavity, concave up and concave down. And conveniently, finding intervals at which the second derivative is positive, that is concave up. The intervals at which the second derivative is negative, that's concave down. So now how do we exactly convert this into an actual answer? Well, as you can see here, from values that go before 0 all the way to 0, it gives a positive value. So that's concave down. And to write this, you would write -∞, comma 0. This, comma 0. What's the next slide? Because this is concave up. Okay.
Top right. There's space in the top right.
Okay, well now we solved one element of the question. Now, now look at the values between 0 and 2. What is that? -12. It's a negative value, right? If it's negative, it's concave down. So you would simply write 0, 2, concave down. Now let's look at the last interval, from 2 to positive values. And let's see what the positive values give you. It gives you a positive value as well. So that's concave up. So the way you would write this is 2, comma, positive infinity is concave up. And notice how I tested the intervals. Upon finding the different x values, the x values that give the second derivative 0, the first intervals you would find is values that go before the first x value all the way to the first x value. Then, as shown here. Then the second interval you would find is the values that go between the first and the second x value. The last interval you would find is the values that go from the last x value to whatever, to positive infinity. Again, it's actually pretty simple. All you need is constant practice. All you need is just to solve. You can't really, there's no real better way to master math than to actually solve them. So, best of luck.